Okay, let me put this into presentation mode. Okay, so hello everybody. My name is Brian Mauldin. I am a DevOps engineer with Verizon Cloud Platform team at Verizon. Let me just get moving here. So who am I? Where did I come from? How do I know Pranethi? So I actually know Pranethi from church. Struck up a conversation with her about 3 or 4 weeks ago. I was asking her a little bit about what she did with data science related topics, and found out that she was actually teaching a course on some of these topics. And then she invited me to come speak, probably because Denton's like mostly like it's like kind of crazy when you meet somebody that actually does something with computers in Denton. It's either music majors, baristas, or yeah, like teachers. So welcome to Denton. I've actually grown up in Denton. I've been here my whole life, so I can make jokes like that. I actually graduated from UNT's computer science department several years ago, back in 2017. But actually, as I've been in school, I've been in the industry in different positions, either as an intern or as a full-time employee, contractor, multiple different fields. I always tell recruiters when they talk to me, I say, essentially, though I go by as a DevOps engineer, I've sort of been a jack of all trades. I've done procurement. I've done product design. I've done industrial engineering. I've done computer science. Almost everything under the sun. I've seen a lot of different things within the engineering field. In that time period, I've learned a lot of things. And even I put a point here, like not just about technology. I worked in a lot of hugely political situations where engineers that didn't get along or thought that the other person was stupid, and you had to learn how to sort of navigate those situations and actually hit project milestones. Sure that some of you guys have been in situations like that, no doubt. As I said before, I'm currently with the Verizon Cloud Platform team, and I'll get a little bit more into that here in just a bit. And last point is I know practically nothing about data science, which I was wondering, I thought maybe if I'm going to talk about what I do, then I'd try to at least go through some of the things that I've done that I felt maybe had something to do with some of the topics around data and finding patterns in data and machine learning in data. Though I know nothing about it, I could sort of surmise some ideas out of that. So projects I've worked on, and I'm going to look more sort of focused on projects that I've worked on that I felt had some sort of connection maybe to some of the topics that you guys have addressed in the class. So let's see how this goes. So one of the first things I ever worked on as an intern was a project called PinView. This is a product that utilized computer vision algorithms to essentially compete. It was a product meant to compete with Smartboard. And our product didn't have to have the big fancy smartboard. You could actually hook this up to any TV or any projector, and you could write on it as if you were writing on a smartboard. The system actually did work, though we didn't ever get it working as good as we wanted it to. Unfortunately, after I left, the company went under. This was a bit of a Hail Mary project. But what was fascinating about the project is got a lot of opportunity to be exposed to the computer vision world, which a lot of what goes on algorithmically in design on, especially with our product, there was a lot of data collection and then tweaking of algorithms based on data collection, and sometimes even having our algorithms work on that data in real time. One of our engineers was actually working on an algorithm that would do predictive analysis to look at previous data and try to figure out if you were, say, taking the pen and you're moving it across the screen in one direction, what's the likelihood that you're going to move faster, or what's the likelihood that you're going to move slower as you move across, and to be able to sort of predict where the pen might go. One of the issues that you have when you're using a visual system, what we had is if you actually look at the photo, you'll see that at the top, right above where the pointer is, there's a camera. And that camera, if you're moving very quickly, it's looking for targets that we placed in the screen. And sometimes those targets would get obliterated because you're up against the speed that the camera can actually see. So, at the time, this was 2010. So most cameras that were of that size, in fact, the one we were using there was actually from the iPhone 4, I believe. They couldn't really image anything faster than 30 frames per second. And then you have to have the DSPs and all the systems embedded to actually handle that level of data moving through in real time and redraw the mouse cursor on the screen in a way that was smooth. So we had utilized computer vision as well as gyros, accelerometers to help position the system in three-dimensional space and figure out how to map that to a two-dimensional field on the screen. Like I said, data was a huge part of this, both to tweak the algorithms, but also to get feedback loops and actually be able to make predictive analysis. Another interesting project in and around data was right after that, I worked on a team, it was a startup company with the same computer science head that I worked with on PinView. It's a lens tracing program. So we're working on a disruptive product for the eyeglass manufacturing sector. So when you take, and actually I'll just pull mine out here, because if I can get them past my headphones here, but you take a pair of eyeglasses. When they take these at the optometrist, they're actually going to, when you decide which frames you actually want, usually what they would do is they would send these back to a lab to be traced. So they would trace out the actual opening, and then they would cut your lens in with your prescription to fit inside of the lens. For the longest time, you would think, well, why don't they just have a database of all of these? Like when they manufacture these frames, why don't they just have a database that shows, what is the size that goes into this? And then they don't have to send these things back and forth in the mail. Well, the problem was back in like the early 90s, most manufacturing was just not to the level where they could guarantee that this would be the same size every time. And so lenses would, if you did that, lenses would actually sometimes fit and sometimes they would pop out depending on the tolerance of when the frames were built and where they were built in the world, et cetera. So we were coming up with a system that was a contactless tracer. You can see in the picture here on the slideshow that you have this little sort of arm that comes up and it traces around the frame. This would take roughly 5 minutes per eye hole, like per eye on the lens to do accurately. The system that we were doing was going to do all of this with computer vision and lasers and would be able to do it in about 5 seconds. So when you're running at a lab, for example, which our biggest customer, VSP, which is like the largest eye insurance company in the world, almost, I think the second largest, they claim that, this would literally cut their cycle time by 3/4. They would have things sit back to the customer almost immediately. So some interesting things here. I mean, we dealt with a huge amount of data in this system. One of the most interesting things I think was with coming up with ideas for VSP around data they were collecting from actual frame cells. So, i.e. things like how many frames are you selling? What particular types of frames are the easiest to trace? And how can you increase sales in those frames, make those the style, right? As opposed to the stuff that's really difficult to cut out. So for example, even in this example with the metal frames here, they're actually much more difficult to cut for than these plastic frames like what I have. Incidentally, it's why plastic frames are much cheaper. If you ever go to the store, you'll find that the metal frames can sometimes be more expensive just depending on where you're at. So we got a chance to kind of get our hands dirty a little bit with the data side of that, though I myself didn't touch it as much. I did have an opportunity to work with VSP and coming up with ideas in that area. So moving on. After that, I worked for a team at Ericsson. We were doing cycle time analysis for work orders in the field for cell site build-outs. This was particularly back in 2013, 2014. So there was a lot of 4G build out with both Verizon, AT&T, Sprint. Our primary customers for our team were AT&T and Sprint. On this project, we built out basically we were analyzing cycle time from work orders in the field. So technicians would go, they would do one particular task on the cell build out. So you might have like 10 or 20 teams that were doing different things, like put the tower up, climb up to the tower. There's, a team that climbs up to the tower and places the transponder on the tower. There's a team that comes in and hooks that to the base station, team that builds the base station. And our customers would want to see things like, what is the overall cycle time? What is the cycle time for team A to do their job? When they started, when they finished, did they actually finish? Do we need to adjust those times? So we were accessing an API endpoint that we were basically putting together a weekly report around cycle time analysis. I was introduced in this project to Tableau, and we were using Tableau to get at this data very quickly. When I was there, I actually had to build out a system, like an ETL sort of system to get data out, because we didn't have direct connection to the API. So we had to do all this weird, like downloading Excel files and scrubbing them, and then bringing them into Tableau, and then doing all these things that Tableau wasn't really supposed to be able to do. And so I utilized a lot of software programs at the time, like even pulling it into Access to add new like calculated fields, things like that, to get some of the reports that we wanted to see and the correlations that we wanted to see visually. I could have seen a ton of thoughts around even just machine learning and how things could have been really interesting here. I even mentioned on the slide, we always sort of pied in the sky about what if we were able to correlate different data sets, like the weather that day versus, or, the weather for a particular area like New England versus how fast the cycle times were. What was the diet of that state, or, I don't know, some random thing, to see what would cause like a particular area, other than, sort of things that you would think of, what would cause, say, taking a particular tower longer to build than in one area versus another area. Tons of opportunities for some big data analysis here, and it was big data. There was a lot of information flying at us. We got those reports mostly automated, and that was a pretty interesting project, especially with Tableau, to see how powerful of a tool that could be. Highly recommend it. I'm sure a lot of you guys have used it. Another Tableau project was a company here in Denton that they do animal care products, and specifically they do survey. They have a survey system that kicks off for animal hospitals around North America, Mexico. It's a program basically that looks at sell orders or receipts that come into the system, and it kicks off surveys every time somebody comes to the clinic to try to get more ratings participation and get more people on Google reviews, and actually, leaving good ratings when they're happy with a particular hospital. One of our customers, or one of the customers that knew we had access to a lot of this real actual data, was Simparica, as well as a few of the other heartworm medication drug companies for dogs and cats. And they wanted us to build out a bunch of reports around basically showing real live data on how they were doing across North America. Where were their weakest areas? Where were their strongest areas? I don't actually have the reports here, unfortunately, but I think Simparica was doing great in Texas, but really struggling in other areas, for example. So we were able to put a lot of reports together around that data. And actually, while I was there, we had hired a machine learning expert that was, sort of a PhD, like in the data science stuff. And he was supposed to, sick his algorithms on it to find correlations and patterns within the data that we just would never think of, right? Things that we might find correlations within all of these different hospitals that just a human being wouldn't come up with. So he was finding some interesting things. Unfortunately, I didn't stick around long enough to see all of it because Verizon picked me up. What do I do now? So now I'm in DevOps. While I was there at Animal Care, I was actually doing sort of half data analytics and reporting and half DevOps for the development team. You might ask, what is DevOps? I actually had to look this up because I got into this field. Um, I guess about 4 years ago when I was at Ericsson, I started getting exposed to a lot of these tool sets like Ansible, automation tools that were sort of around the concept of development and operations. One of the projects that I was doing at Ericsson was a learning project to build out an entire um, OpenStack installation on a actual subset of servers, switches, all of, sort of like a little mini data center. What they wanted to do is sort of automate the entire process from start to finish. Go in, log into iDRAC on the Dell servers, set up, bring up a machine, set it up with an OpenStack version. Basically, with the push of a button, you would have a cloud just like that. And so I got involved with a lot of these tool sets, and then I got brought in when I was animal care because they found out, oh, you know how to work with Jenkins, and you know how to set up a continuous integration pipeline and a continuous deployment pipeline. And they basically were like, you don't have a choice. You're going to be doing this because you're the only one that knows anything about it. So that's how I got into it. And Verizon actually recruited me via LinkedIn, and I ended up on the Verizon Cloud Platform team. And since I've been there, I've been doing a lot of uh, I'm getting a little ahead of myself here. Actually, Verizon Cloud Platform, what we do there, we actually have the second largest cloud in the world. I believe it still is, internal cloud. So, like AWS, Azure, Google Cloud, DigitalOcean, for example. Those are all public clouds, but ours is only internal, and then for our own internal customers as well as customers that we decide to work with. Huawei is the only one that beats us on it. They have the largest OpenStack cloud in the world, largest private as well. But ours might actually beat them by the end of the year. We're tripling the size this year. So um, we have it split into multiple regions: light, edge, core. Most of my team works with core. A lot of this I'm not super involved in. What I actually do for the team, and I just provided a link here. We might even send this out to you guys. This is a link to our director for Verizon Cloud Platform talking about what we've been doing internally with OpenStack and how we set up our infrastructure across Verizon and worldwide across our data centers. Let me see if, there we go. So what I actually do, I work on a team called the Verizon Cloud Platform UI team. What we do, we build sort of this user interface to the system. A lot of this is just a website with a bunch of analytics. So we might have things like, we have a program called ArcGIS. We use ArcGIS for visualizing all of our data centers, where they're at in the world. We have a couple of people on our team that build out that system and manage it. I manage, basically, I am the support for all of the back end and the front end. So anything that's being set up, I am initiating CI/CD pipelines for that using a tool called Screwdriver. It's a little bit like Jenkins. I'm building out, supporting and keeping the systems up and running. I'm building out basically anything that's needed to keep our infrastructure up for all of our UI applications within the OpenStack cloud. So all these virtual machines we're running, I'm making sure they're staying running, and I'm usually the one building them out in the first place. So managing all the infrastructure automatically. Currently, we're working with a tool called HashiCorp Terraform. We're moving a lot of stuff over to that at the moment. So it's interesting about some of the stuff we do there, though I'm not as directly involved with it. We do a lot of data analysis. We actually have a guy that's been hired only to do data analysis with Tableau, and we have tons of reports we have to show to the rest of the cloud team. Show things like, monitor our systems, our cloud across the world, show projections for build out forecasts, actual on what we actually have built out in the field. We have a system called Rack Viewer that goes and uses a back-end system that's designed by one of our team members called Galactus, and that literally crawls through all of these data centers. It collects BIOS information, switch information from every single piece of hardware that we have, builds this giant database, and then we query that database through an API that they've written. And we have a thing like a tool called Rack Viewer. We can literally like go to a particular area like Dallas, and we can see all of the racks, like the actual physical systems, even where they're located within the data center based off this database. So, and if you ever get the password to that, I would have to kill you because you would know with everything that's going on within our team internally. So lots of stuff going on there with data, and a lot of opportunities too for probably more on the business intelligence side. But there has been some conversation within our team about even bringing in some machine learning, especially when it comes to figuring out how we can, for example, auto remediate when we have outages, things like that. How do we predict outages that could potentially happen, their severity? How can we do better with even our firmware upgrades and serving our customers? So fortunately, I can't show you a lot of pictures. It is an internal tool, so we're not really allowed to sort of talk about all of the different things that it does from a deeper level. But, so kind of a boring slide. I have just flooded you guys with information. And I realized that I didn't do a lot of effort in defining DevOps, so there might be some questions about that. But does anybody have any questions or anything they'd like to know more about, or more about what I do, for example?
Hey, Brian.
Mm-hmm.
Paul here.
How's it going?
Good. Yeah, I was just wondering, like, what kind of CI tool do you use? You mentioned like it was something like Jenkins, but what was it?
It's actually called Screwdriver. It's made by Yahoo. It was an open source project from the team at Yahoo. We own Yahoo. Verizon bought them out about 3 years ago.
Yeah.
So we're sort of forced to use it. It's not great. Don't use it. I'm just telling you, Jenkins is hard to use, but it's a jack of all trades. I would say one of my favorite tools, actually, GitHub is designing their own right now, and GitLab actually has one built in.
I've heard of that. Yeah.
We're switching to them. We'll be switching to them this year, actually. So we're going to be dumping that at junky software. Thank you. Don't let Verizon hear me say that, because they had to use what was designed internally. So big company, corporation, so politics.
No, I can understand. Like, I remember, like, I was like working for Ericsson, onboarding our applications on Verizon Cloud.
Right on.
Like that time, you didn't have any CI tools. It was just some guy. Like, we had some. I forgot that name. Like, there was a tool from HP that you used for orchestration. Again,
that sounds awful already. I'm sorry.
But again, most of our stuff, they were like telecom applications. So we used to use like VNF managers, something from Ericsson. And again, like Verizon guys forced us to use that HP orchestrator something. But so now, like, everything is in a pipeline.
For us?
Yeah.
Well, so for VCP UI, we have that entire project in the pipeline. Yes. Oh, you're talking about Ericsson at the time.
Not Ericsson, like per se. Like what if I have an application that I want to onboard on Verizon Cloud? How do I go about it now?
Oh, so at the moment for the Verizon Cloud platform, that process is not fully automated. Funny story about that. It was actually at one point, but our executives didn't like it. They said it was too fast. They wanted to slow everything down. Go figure. So, so now it's still a ticketing system where you have to request project space, and then
I remember, like, we used to ask for the requirements, and then they used to create tenants and based on our requirements, and like
Oh yeah, there was proposals to make that a lot better, but they all got shot down at the tops. So, so.
No, but it's interesting. Like, I remember, like, when like Verizon bought Yahoo, and then there was also this switch to using Gmail servers, and like you guys had trouble attaching mails, and that was busy times. Yeah.
And now they've switched it back because they said, "Oh, Gmail's not." It's like It's like it just says you're getting into one thing. You're like, you get really good at one tool, and they're like, no, we're going to use this one now. So we've been going through transitions again. Even with GitLab, for example, like going from using Screwdriver to GitLab, it's like, oh boy. So for any of those who have been in academia for a long time, just get ready for that when you get into industry. Where you like learn Tableau, like really good at Tableau, and they're like, nah, Power BI, we're switching. Go learn it. Like, okay. So.
That's interesting.
Mm-hmm.
Yeah. So
Any
like,
other questions?
so as a DevOps engineer, like generally asking, like I'm hoping like, your repository is linked to that Screwdriver tool, right?
Yeah.
So anytime there is a change in the repository, like it makes a build and then it goes on and deploys in Verizon Cloud. Like what kind of like issues do you as a DevOps engineer face on a day-to-day basis, and like what does an ordinary day look like for you?
Okay, so I'll answer the first question. So issues that I face on a day-to-day basis, I'll first start by saying that if I was working with a public cloud, some of the things that I face probably you wouldn't face. So like there's a lot of DevOps engineers right now. Like DevOps has become a buzzy word to refer to basically people that can build out systems in AWS or Azure. But from what I experience on my daily job, we would generally, I'm kind of a split between two roles. So DevOps, sort of pure DevOps, would be somebody that's just building out those continuous integration, continuous deployment pipelines. So when I got to the company, a lot of those pipelines were already in place, or at least maybe in place, but just needed to be tweaked a bit. So like the VCPUI pipeline was built out. Um, they make a change in GitHub, say to the develop branch, they push or do a pull request on that branch. It will build out and it will actually deploy the application live to one of our develop nodes. So one of our develop VMs in OpenStack.
Mm-hmm. Mm-hmm.
And actually, just to sort of address that as well, we started off using for containerization orchestration, we use Docker Swarm. We're switching currently to Kubernetes, which Kubernetes is sort of taking over the world right now.
Mm-hmm.
Anybody that's within building applications now should at least know what Kubernetes is, just period. It's the tool it's how you package software. It's containers, Docker. If you don't know what that is, go learn it. Everything uses Docker. Docker is the end all be all of all things. But basically what our pipeline does, essentially it builds out, it tests the code using, we use Node.js. So all of our stuff is built in React and
Okay.
then Node.js in the background. So VCPUI uses that. It builds it out. It creates a Docker image, pushes that image to a repository, logs into the manager node on our whatever swarm we're dealing with. So either the production environment, stage, or develop, and then deploys that every single time a change is made. So if a pull request is made and it's merged to say stage, within about, I think our pipeline time right now is about 20 minutes, you're going to have the new version of stage up and running at the URL for the stage system. So daily though, outside of that, I do a lot of site reliability engineering. So designing the pipelines is one thing. The other aspect is building out the virtual machines for each environment, managing the infrastructure, managing uptime of systems. So I would say probably 70% of what I do right now, especially because we've been kind of needing some help in the DevOps side. When I got to the company, I did a lot more site reliability. So I do a lot of like, a node goes down on the Docker Swarm. I got to get in, SSH into the box,
Uh-huh.
try to figure out what's going on, get the box back up and running, make sure the swarms are monitored. We're working on getting the monitoring aspect of DevOps now. There was some things that were done and some things that weren't when I started. So my day to day, it's probably not the average DevOps guy's day to day. It's a lot of site reliability, Linux administration type stuff, mixed with
Understand.
development. So
No, totally understood. Yep.
yeah,
Yep.
yeah.
Good to know, like now that VCP has got support for containers also, because like I'm talking 2.5 years ago, you did not have that capability.
Oh, yeah,
Yeah,
it's come a long way. It's come a
yeah,
long way.
and it's still based on Red Hat, right?
Red Hat OpenStack. That's
Yep.
correct.
Hmm.
Hmm.
Yep.
Yep.
To know.
We went through a lot of political changes at the company. So we had a director that was let go, a new director installed, and then they cut the team about three quarters. I joined after all of that happened, so I wasn't there when all that happened. But
Yep. Yep.
yeah, a lot of reorganization. But it is coming along well now. So and I think our cloud has a lot of potential, but that's a whole nother conversation for a different day.
No,
Any other questions?
I'm good. Like good talking to you, Brian.
Yeah, thanks for the questions, man.
Hmm.
I think Srinivas has two questions. Srinivas, you want to say it? I think you're typing it in the chat. But Brian, his question is, what are the advantages of DevOps and does it require coding?
Yes to both. Well, not a yes to the first one. That doesn't make any sense. The advantages of DevOps are that what you're doing is you're changing the mindset. So in the kind of little cycle photo that I gave you, um, really the idea is that in the past, when you would develop code, you'd have a team of developers. They would develop a web application, say, for example, and they weren't really thinking about how that would actually be deployed. It was more just like, okay, I'm running it on my own little individual environment. I don't really care about how it's deployed out to the data center, out to, where is it going to run? How resilient is it going to be? How much load is it going to be able to take? I'm just more concerned on which color this button needs to be on the UI and making sure that that connects properly to the backend APIs and that they can handle the load. So there wasn't a lot of thought process of like, what is this thing going to be doing in real production, right? Then they started to think about this idea of DevOps, where it's like, instead of the developers building out, say, a node application or a website, and then just throwing it over the wall to the IT team and saying, hey, figure out how to install this and get it working, right? They were thinking, how could we integrate those two processes together? So the idea is that the developers themselves would be more conscious of what they're building to production, so that they're more aware of how they're packaging their code so that it runs in essentially runs with little to no configuration within a production environment. And I think more or less DevOps has achieved that. You heard the conversation I was having earlier about containers, about container orchestration. That has been the biggest tool that has helped bring DevOps to the forefront. Because really, without containers, DevOps is very difficult to do. But more or less, what you're doing in DevOps is you are rethinking how you package your code, and you're thinking more. You're basically being nicer to the IT team and how you're putting your code together in a way that they can just literally take it, push a button, and it deploys out into whatever you need. Second aspect of DevOps is that it provides automation between those two tasks. So in the olden times, what you used to have, if you remember like Windows 95 or old school like software packages like that, you would have, okay, we're getting all this code ready, and then we're going to release Windows 95 2.0 or something. And it's going to be this big release, and we're going to release all this stuff. And then we'll get it out there, we'll deploy it, it'll go to these little CDs, and you'll stick it in your computer and you'll install it. Whereas DevOps would change that to where anytime a change is made and you're ready to push it to production, within 30 minutes, I mean, you could literally change a version of like you could go through all the way up to Windows 10 within 2 days, right? So you could be sitting there writing code, you see a bug, you can get it up to production almost immediately. The biggest drivers of the DevOps ideology, not surprisingly, was like Facebook, Amazon, all those big web application companies, especially Facebook. I mean, Facebook literally is making production changes to their website over 120 times a day. They're changing things. You don't see it, but they basically have all of those things being updated around robin style on their systems. They're making changes constantly that's going straight to production. They don't do versions. They don't even have versions of Facebook. They haven't had it for quite some time. So
Is there
yeah.
any certification that we have to, complete for DevOps? Like AWS, there is DevOps engineer.
Yeah, those are helpful if you're going to work with AWS. I'd say I'd say that there's sort of some core ideas that I would say you need to have a good grasp on. Virtualization is one. What is a virtual machine versus a physical machine? What is a container? Um, you need to understand a bit about how web applications are actually deployed into the field. So like those three things really: container, virtual machine. How do you package up a particular application into a container, build a container, run it? And then CI/CD tools like automation tools like Jenkins, for example, will be a great place to start. Learning how to use Jenkins, set up a pipeline to say connect into something like a GitHub project that you've created, run a build command, and then deploy that to a Linux server that you have, for example, and then be able to do that every single time a commit is made to the code. Which is another key tool. I mean, really, Git is sort of what brings everything together. Linus Torvalds, when he wrote Git, I don't think he really foresaw this, but Git, that tool in general, has enabled the DevOps methodologies for the most part. Because the idea of being able to pull requests, being able to live make changes between an entire team of 100 developers. I mean, you could literally get something from develop up into production and have it automatically pushed every day. No IT people in between, no middleman in between. Just go straight there. So as far as certifications, the AWS stuff would be helpful. I would say I've worked with some AWS. I'll tell you, like, just from my experience, I've just been interviewing a lot of DevOps people. I got into this field. I have maybe 2 years experience now, but I don't know anything about AWS, nor do I know anything about Azure. And unfortunately, I would say my biggest complaint about some of the candidates that I've seen that we've had to deal with, and not just myself, but one of our lead developers is a computer science major. He graduated from Harvard, so he's no slouch. Very, very smart guy. And he was complaining about the same thing. We were talking about the fact that we have all these people that have a list of certificates, like from AWS, but they only know how to do anything in AWS. They don't understand what they're doing. And I would say, like, placing an emphasis on Linux administration, especially being able to know how to get into a system, troubleshoot, look at logs, figure out why something's not working. That is just a key. That's just a key to DevOps. I mean, that IT side is absolutely necessary. You can know how to set up a virtual machine. You can know how to do all those things, but if you can't troubleshoot a down system, you're useless. Site reliability is becoming a big deal now because of DevOps, because now you're putting all these systems out there, all these VMs are running in the cloud that are running your application, and now you need somebody that can auto remediate issues, figure out how to get in and keep the site reliable, right? So kind of the IT aspect, at least on the software side, is sort of disappearing, where IT people, all they're really doing now when it comes to application deployment, they're not installing any applications, because the applications now are just installing automatically 100 times a day. What they're doing now is they're just managing the hardware itself. So the AWS stuff would be helpful, but I wouldn't put all my money in it for sure. I would maybe start with just getting your hands on some of those tools that are open source and playing around with automating the deployment of an application. And I'd say if you can do that, then you're 70% there. So.
Thank you.
Mm-hmm. Was there one more, Pranethi, or is that it?
I think, does anybody else have any questions? Okay, silence. Like I said, nobody wants to talk. All right, thank you, Brian. And it was so good to have you. And yeah, definitely bombarded us with a lot of knowledge. Then let's see how people are going to react to this.
Yeah, sorry for the little bit of the mind dump there, but not sure what all that has to do with data. But I would say, you know, in the future, obviously there probably will be some areas where data science and analytics will play a part in some of these fields. So thank you, guys. Appreciate your time.
Thank you. Thank you for coming.
Thank you. Thank you.
Yeah, appreciate it.
Thank you, Brian.